Hello and welcome. I'm Bill Wake. We're here working today on recursion, basically. We've been using the Towers of Hanoi as sort of a test bed for it. And what I'd like to do today is actually introduce the stacks that the tower is supposedly manipulating. We've gone this far without them and trying to visualize things more. So sometimes that turns into watching me struggle around UI, but we'll see if my ideas are going to work today. All right, so to remind you of the problem, the Towers of Hanoi, you've got the stack of disks on the left. You're going to move them one disk at a time, and you can't put a bigger disk on a smaller disk. So to move them, you have to move part of the stack and then make some room and then move the bigger disk and so on. So we've got an algorithm for that. We've actually had about half a dozen algorithms for it. But today I'd like to at least have the stack in place. I don't know if we'll get to visualization or not. So let's go to the IDE. All right, so to get here, I've run the tests that we have so far. And last time we left off, we modified our move to basically follow this recursion elimination template that from an old article, and it basically introduced two stacks. We optimized things enough to realize we didn't need two stacks to do that, just one, and the recursion elimination basically got rid of the tail recursion at the end, and I think we're going to leave that behind and go back to the original algorithm that we had, or something like it, which is this one. And let me move it up here. Now let's move it all the way up. And we'll hide this one for now, probably forever. Okay, now this algorithm is the one we worked from to get the recursion elimination going. We took out the notion of returning a string, but let's add that back in. And I don't think I kept the right intermediate version for that, so we'll just play it by ear. Okay. For an empty string, we'll return nothing, and then we'll say left equals that. And right equals that, and we'll return left plus middle plus right, and then up here we'll return output. Binary operator plus cannot be applied to operands of type string and nothing. Middle. Oh. Let's try an arrow going the right way, see if that helps anything. Right. And let's see our tests. Well, they look at the log, but we'll run them just for... And let's capture that. Okay, so we have our choice of either picking it off from the log or from the output. This one is more for our amusement. It covers the case. We just want to run it and see something happening. And I don't know, we used 5 a lot. All right, so let me run these again. Okay, so we are at the point of We have a recursive routine because it calls move. It's progressing on the recursion because it always reduces the number of disks, and at some point that becomes 0 and we return. And that's pretty much what goes on here. All right. So what I'd like to do, well, we introduced this stack yesterday, and I think we can use that to represent the contents of the 3 towers because the towers act like stacks. Okay, so now I guess the I'm just going to use those tests we have, and I'm introducing stuff that doesn't, well, it's going to manipulate it, but it doesn't care. Okay, so let's create the pegs. So let's let the pegs equal an array of 3 arrays. So this is going to correspond to 0, 1, 2 in our peg numbers. I took a note somewhere here. Yeah. I can say 1 dot 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 to the size. Okay, so where are we going to tell the size? I guess we'll create an initializer. Okay, so you'll have to give that in the constructor. Let's see who's complaining. Well, this one doesn't matter. This one should probably be the 1, 2, and 3. And 5. Okay. Nothing's happening. That's tower. We'll start that one small. Didn't realize that would have such ramifications. All right, so we'll run this test. Then we'll make the tower create those 3 things. So let's, well, almost everything in here is kind of arbitrary. So let's put the pegs is going to be equal to array, and this time we'll do this in the constructor. It's an array of arrays of int. Okay. So we're going to say pegs equals array 1 dot 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 size, array of nothing, an array of nothing. Okay. So array. Okay. This gives us the pegs. Then the move. Let's make it do something. Move something. Okay. So when you move 1, we're going to assume the array is filled up. I guess from your left, 1, 2, 3, 4, 5, 6. On that way, the last element is going to be the highest, and we'll treat that as the smallest disk. Okay. And then we'll treat the array as, well, that's interesting. It really should be a stack, shouldn't it? Array of stacks. Can I just do that? I don't have this in there. Okay, I have 3 stacks. Can I convert value of stack? Oh, this should be a stack here too. Okay, corresponding to my 3 stacks there. All right, but we need to initialize this one. So let's give it. Let's give it an initializer. Maybe we'll put a test in for this one just to be interesting. Okay, nothing allows this yet. I'll even use 2, just so I'm not asserting all day. Okay, first thing, top thing on the stack should be a 2. And then the next thing on the stack should be a 1. Okay, is that confusing? All right, so it doesn't like that the argument's passed in. So let's add an initializer with an argument. Okay. And I haven't played with the ranges enough to know what it does about 1.0. We'll have to see. Oh, that's our new test failing, I think. Yeah. Okay, we like that. So we're gonna reinitialize stack equals array of 1 dot size. And that may blow up if the size thing is not. Something's weird. Close range is expected to be an instance of a class, or can I say array of int? Oh. My type is T is supposed to be generic, and here I am showing ints in it. Okay. That's not going to work. Let's give it the elements. I don't know if I can do this. Oh, dear. It's like I want to make it convenient, but everything I'm doing is not making it better. Can I say T of comparable? that's not going to work. No exact matches in call to initializer. Oh boy. Well, maybe I'm just being too clever. Maybe the job of this thing is to just put those things in there. I think I can do this. Peg sub 0 dot append 0. Okay. Let's see how that does. We're not looking in the stacks, so I'm not sure there's going to be much problem, but okay, so that's fine. Stack. Well, this doesn't add anything then if we're not doing the work inside the stack, I guess. Okay. Right. Okay. Now, what I'm saying is we should be allowed to actually move the stuff from and to, move disk from peg from to peg to should actually do something. So it should do peg sub from let disk equal peg sub from dot remove last, and then peg sub 2 dot append disk. All right, and value of stack has no, oh, did we say pop and return the value? Yes, we did. And push. Okay. Now, do I want to print those disks, those stacks out? I don't know that I do. Well, let's just see if things run. If nobody blows up, that's a good sign. And there's no harm in it. We're just keeping track of things. Okay. Okay. So the one thing I was going to do last time, let's go to do. Add a helper peg method. Okay, so I kind of jumped ahead to this. We added an actual stack. Let's see, today's the 6th. Whoops. Whoa. Don't do that. How do we get back here? All right. 0506. Record. 3. I put 3 zeros or 3 digits for some obscure reason. And usually I stack these as well. I guess it's 2 stacks. Okay, so the recursion part, we added actual stacks. Okay, but I also want to do this helper peg method. So the helper peg is we've got duplication. Let's get rid of our duplication. And the duplication I'm talking about is 3 minus from minus 2 is really calculating a distance. So let's see how close I can get to a smooth refactoring with Xcode. I'll extract the variable. Okay. And I'll extract a variable. Oh, no, I won't, huh? Oh, annoying. Okay, so this, well, we can extract a method, but it doesn't, oh, it does take from and to. Okay, well, that's good. And this is, what is it? It's the helper for from and to. It's the spare. From and to. I think that's correct. And then I'll just inline this manually, unfortunately. Okay. So I can use that same thing here. Okay. And I think we can take these out. I guess my claim is that helps the readability somewhat. It's move some disks from the from to the spare, and then move the bottom disk from the original to the target, and then move the rest, the disks you just moved, the big stack, from the spare to the to. Okay, I like that. I think that's a worthwhile if small refactoring. All right. Let's run these tests. Oh, I don't really need that comparable on here anymore. I'm getting something that says my stream is not streaming. I'm hoping that's a weird artifact on the Twitch side. But I will commit this, and let's see. Whoops. Commit this. All right. So we I guess we basically restored a simpler version of the solution. Then we added actual pegs using our stack, and we extracted a helper function spare. Yep. Okay, the video kicked in again, so I believe I'm here. There. Okay, so I think in terms of what we were trying to do, let's see, we did the elimination last time. All right, so I think we're up to the visualization, and I did a little work after seeing you on Monday or Tuesday. So Tuesday's session, I wrapped up with some work on the UI, and then kept going for probably a couple hours trying to do things. All right, we don't really need this. So I don't know if you've run across this in Swift, but Swift UI, they've been making it so that you can do this Swift UI approach with these view objects that are kind of textual view objects rather than the manipulated ones, so that they can handle resizing and things like that more automatically. This just says, how do you kick it off? Well, you kick it off with a content view. Content view is the bulk of the UI. So our original this is an example somebody had. All right, so junk. All right, so what we have is counting the number of calls, and I don't know, run count. What is that? It's this thing. Okay. Yeah. So what I've done is we have the count, the state count, which is kind of a local count that lets me monitor what's being displayed, and a go button. So let's just run the app and see that. Now the problem we're having is when you kick off the run, we would like our counter to say, oh, 1, 2, 3, count the moves, but nothing happens until the whole thing's done. Oh no. Let's see. What are we actually calling? Tower.move 15 from 0 to 2. Well, let's reduce this to 5 so we can track things a little easier. Can't remove last element. All right, let's go back and make sure these tests are looking kind of right. Well, just run this one test, so we'll be running the same thing. Are we calling move 0? Okay, it didn't blow up. 0 to 2, 0 to 1, 2 to 1. That moves the first 2 disks. Zero to 2. Okay, that moves the little tiny one. 0 to 1 moves the medium next one down. 2 to 1 moves that one down. Then we get the third disk on the target. And then back and forth. Okay, that all seems okay. Let me remember. Whoops. That was test. So count is the number of moves so far. State and this go. And what are we doing? From all right, let's look at pigs. It's not going to make it easy to look at. That's one reason I want to visualize it. Okay, so peg 0 says it's empty. Empty. This one better have the values in it. 1, 2, 3. Oh, have we initialized something wrong? I bet. Tower sub 5. Well, we've lost 2 disks, I guess. If this thing really is 5. So does our build create it? Well, we're gonna start up here and check out what pegs is, make sure it's being initialized properly. Oh, is it, where is it being initialized here? Yeah, we do tower sub 3. Okay. That's, yeah, we'll parameterize all that, I promise. Well, maybe not. We've got an hour and a half to go, so if we get there, we'll do it. How's that? Let's run this one more time. I can take out this breakpoint. Okay, when I click go, it should run the tower algorithm. Oh, is it not? I don't know if it did or not. Received A0 async returned. Okay, so, well, what I'm trying to see happen is, maybe I should tell you what I ran into. So if I don't do this dispatch queue, this is where we left off the other day, more or less, I guess. So if we don't do the dispatch queue, then the move, the screen doesn't update until this returns. And we're trying to capture the changes of the number of calls. And that's a value we want to see keep updating. So what I tried to do was do this received updates thing and try and capture those values as they're coming in. But let's see. Well, this should. I'm feeling like something's off. I don't know what it is. I'm not seeing something that tells me it's off, but that was surprisingly quick. Okay. And nothing printed. So we did stop printing. Do we have the delays? Maybe we took those out. Yeah, we took those out. Okay, so let's find a version that has that. Okay, this is the kind of thing we want. And I don't have a good solution. At this point, I'm trying to do two things. One is I'm trying to control my app so it runs more slowly, so I can visualize it and watch it go. And the other is I'm trying to capture this stuff and visualize that. So all we have to visualize right now is number of calls coming in. This slows it down by a factor of a lot. It says sleep 1/10 of a second between every move, or before making the move. So 63 moves, 6.3 seconds give or take to do it. That should be coming from that. So, and then this number of calls is a published field. Is a published field. So it's supposed to automatically call send, object will change dot send whenever it updates this field, and then that gives the UI a chance to redraw. All right, now I think we're going. Okay, that's running slower like it should, so I think the delay is in place. But notice we didn't get incremental counts, we just got a big 63 at the end. All right, now, but let's run it again. Okay, it's frozen. Oh, It's not designed to run again. Oh, drive me crazy. All right. We can fix that. Content view. Where's our go button? We'll reinitialize our tower. Okay. Get only property. All right, let me take that out. See, I need to focus, right? Like we got multiple things going wrong here. So what are we solving? All right, we just solved the fact that it runs too slowly. Now I want to see the async stuff happening. So I'm going to kick it off. It's going to take 6 seconds. But while that 6 seconds is going, I want to see my notifications of these received values. And I didn't. They all blocked up until the end. So my thought was, oh, I'll just spin this off on a thread. Okay. And so let's do this again. All right. And again, we're going to kick off. It's going to take about 6 seconds. But this time I expect to see the updates as I go. So what I can tell is the number of calls is being updated while we're doing the work, and we're receiving it because that's the on receive, print the value. Okay. And this was my attempt to force it to redraw it. But these were happening simultaneously, but nothing updated here until the very end. So even though the drawing part of the content view got notifications like, oh, the count updated, the count updated, the count updated, it wasn't free to redraw until it does the redrawing on the main queue, I guess, is the deal. So my thought was, if I run this, let's see, where is it? Okay, there's the main queue there, and that's the one that the drawing part of things does. So I think I need to be running off a different place, and I think there's one called global. I think I can do this. So I'm saying spin off my work in the global queue, and then the updates received, those I'm hoping will show up in the main queue. And as each one comes by, I'm hoping it can redraw things. So this was my big idea for solving this. If it doesn't work, I'm not sure what I'm going to do. So I guess I will try if I can create my own queue or my own thread, maybe. But it'd be better if this just updated. Yes, thank you. Because when you're scraping the bottom of the barrel for your ideas on how to fix it, it's like, oh, goodness. All right. I think the state count thing is just, that was me trying to debug my way into it. So I don't need this anymore. Let's take that out. And thus we'll take this out. Okay. And this is number of calls. And that we don't need. Okay. I don't know if we need this piece, the on receive, or not. Make sure to publish values from the main thread via operators like receive on and model updates. Okay. Yeah, I'm doing something they don't like. I think I'm legal. Background threads is not allowed. Publish values from the main thread via operators like receive on model updates. Well, we're using on receive, so I think that's that. Yeah, there's. Let's just see what somebody says on this. see you on runloop.main. Okay, this is like the combined stuff, which is their sort of React equivalent. And I'm not trying to use that per se. Missing receive on. Well, unless one of you speak up, I'm going to let it go. I think, let's see if we really need this. I didn't feel like we were supposed to need it, but I was doing a lot of stuff on the way to try and get there. That was weird. Let's try it again. Now we're waiting, no updates. That's annoying. And then a final update, yeah. Whereas when this was in place, it was keeping right up. And this is telling it exactly to monitor that. Yeah, that's what we want to see. I don't know. I want to say I shouldn't have to do that, but I wish I had a pair partner who knew what they were doing with the SwiftUI stuff. I'll just say it that way. And you all are welcome to step up here. Okay. So what my thought is I would like to now try and display those stacks. And I know this gets messy. At some level, I just want to say, why this thing? I can't be the only person experiencing this stuff with the tabs. Where's my tower? Close this. Open this. Publishing threads from background threads is not allowed. Publish values from the main thread. Okay, I mean, this is kind of the warning you get when you're doing things wrong. How do I publish? The challenge I have is I don't want to turn everything inside out, and I feel bad enough that I'm doing this, right? Because these are well, I'm modifying our algorithm. So I'm saying to visualize an algorithm, I'm going to go in and modify it. Well, now I'm visualizing my modified algorithm, not my real algorithm. Updating the number of calls, that's kind of metadata that would be nice to collect. Well, I think if you had the number of towers, if you said, give me 10 towers, and it comes back as 1023, and, I think you'd get this pattern of powers of 2 minus 1. But it didn't like that, and here I am wanting to add more published stuff. Like I would love to publish my pegs. Okay, well, we're at a good point for a break. We're probably even overdue. So let's take 2 or 3 minutes for a break. We'll come back and see if this is something we can work with. I feel like there's an issue. Yeah. Okay, I don't mind a var. It's like we have to set up a 2-level listening thing or something crazy. Again, we're distorting the shape of the result. We'll see if this builds at least. But anyway, let's take a 2 or 3 minute break. We'll come back, see if we can get the stack showing. I would love to have the stack be, 1 through 5, and then number 5 disappears over here and appears over here, and then number 2 appears over here, and then, or 4 appears over here, and then 5 moves over, and so on. So, we'll see what happens. All right. So, see you in a couple minutes. Okay, welcome back. Let's see what we can do here. In our content view, let's display. Can I do this? I would like to do text. Peg 1, I'll lie. And tower.peg sub 0. I don't know what that's going to print. Require stack event conform to specifiable. I think I can give my stack. What is that? Extension. Debug. Custom string convertible. Description, okay. Var description of string. I don't know if I can do it this way. Let's just do stack dot to. Can we do this? Cannot find stack. Require stack of int conforming to specifiable. Well, let's try dot last. Oh, he's my stack now, so I can't. Well, let's just do description. Now, I should maybe try. They have a little preview facility. Oh, that's nice. Okay. Okay. And there's a better way to do this, but I'm just I'm happy something's showing up. Hopefully those two show up with empty lists. No problem. We're happy. All right. Now what I anticipate is things. Well, I hope they move. Oh, they are. Okay, well, let's change our constant. Unless your eyes are quicker than mine. Let's add another 0 on there. So that sleeps a 1 second. And really, that should be a parameter 2. Now that's coming way too fast, isn't it? Well, they're already... Okay, we can't redo. Why is that so fast? Well, make it very clear whether it's working or not. 5 seconds between each one. That's no 5 seconds. Why are you not sleeping? Now, obviously, I would love to have it be a vertical stack. Oops. I just am not getting the sense that it's synchronous. So let's try on self.tower.pegs. No, that's even worse. Well, it's certainly publishing stuff. Well, I'm definitely getting the sense my use sleep is not sleeping. Oh, let's have enough digits to make it do something. Two, 3, 4, 5. Where's your update of the pegs? Okay, so you sleep is sleeping. The pegs are not updating. Oh. All right, let's call a stop there. Okay, so I think this can go down to maybe 2 seconds would be fine. I'm going to try a different approach. I feel like maybe the problem may be the pegs are not changing. They are pointing to the same stacks every time. So let me try a different idea. Let's make published var peg A be of type stack of int. And B is also, and C is also. And I think I can even assign an initial value. I'm maybe moving in. Let's change these back to integer arrays. I don't know if I'm equals nothing. Okay. I'll take this off here. And actually, this is just going to be a let of type array event. Now I'm going to put the pegs in. Is that going to work? The pegs don't change values, so they can be a let. That's fine. And then I'm going to say peg_append $0. So I'm going back to no stack object. Pegs is a let constant. Okay. Well. Okay. Now here, desc from dot, and this is remove last. Pegs dot append. Okay. For all properties are defined. Oh, I think I have to say defer. This says forces at the end of the constructor called before self-used in method. I don't quite see the issue really. These are all initialized. Can I do that? Okay. Do I need... I think if I take the defer off, it'll complain again. No? Okay. Where are we? All right. My hope is at this point, I've got independently published things. My content's going to have to update. I don't know if I have to do this or not, but I'm trying to do it because I'm hoping it forces updates as we go. Okay. So each peg is a published entity. My hope is it gets the updates for those as we push and pop, and that triggers the update cycle on the content side, the content view. Something's still not right. Binding conform to publisher. Is that the publisher? On receive perform. Tower dot number of calls. This array of int. Binding event conforms to publisher. Now this is odd. I mean, we didn't touch number of calls. We'll run this. I don't have tower.pegs with the on receive, but I don't think the on receive should be needed. I'm puzzled by that. One, nothing happening. Two. Well, be puzzled all you want, I guess, but all right, let's try and address it. Maybe I got to put the individual pegs. Seems weird. Okay. So as I look at these visualizations, so what I'm saying is right now I'm trying to enforce that you declare everything published that you want displayed in the update, and it's not doing its thing. All right, let's print them while we got them. We'll just do the one. And let me see if this updating thing will actually do its job. All right. This is supposed to let you run stuff like this in the IDE. Can I hide that? No. My experience is it doesn't seem to do very well. It's always getting stuck and stuff like that. But we're just displaying stuff that's all either kind of computational if it's our tower or these fields that we're showing. And that guy's, oh, he's still running. Let's stop that one. Resume this one. When this is working, it's nice. You can edit stuff on the fly and kind of easily change it. Wanted to give it some amount of time to run, but having it takes a minute to start up is kind of ridiculous. All right. Yeah, so I'm kind of going back to my what I'm requiring from an algorithm is anything you want visually displayed, you're going to have to make published. Otherwise, I would wrap. Well, it's kind of this challenge of getting control of something that's going on. So if I don't do that, like if I try to create a separate wrapper object, how would it know that the thing changed, right? There's nothing that would tell it. So I'm going to have to introduce some publish mechanism, in which case I may as well just let it publish its own stuff. Failed to launch in a reasonable time. Yes, I would agree. What's the issue? 15 seconds. Yeah, right. Just did not launch. Okay. I'll give it one more try. Okay. Yeah. Now, the thing I can do, I can do this stuff. It's supposed to just keep up. Yeah, so it sort of keeps up. But if I make anything that's a moderate change, it's gonna have a problem. And what it's doing is it's just calling content view. You provide this little view. You can show different phones and stuff like that if you want, different sizes. But it's just calling my main view in something that is known to be a sort of a default name for preview providers, one of these. All right, I think, can I click go? I don't think it runs my, yeah, this is more a visual design kind of thing. Well, one thing I was wondering was, can I rotate? In fact, 90? Cannot convert into expected type angle. Degrees 90. 270. Okay. Let's make this a vertical stack of these three things. And then I'm going to put this on there. I'm happy to take off this label. Now I don't know how it's going to know. Let me put some space in here. So it's supposed to give you, some opportunity to control the visual design a bit interactively. In the old style, you just drag and drop, but you ran into the issue of like every tablet, every phone was shaped a little different, and some of them have a little notch on the bottom, and some have a little notch on the top, or whatever the issues are. Okay, but I don't think this gets us very far on the actions. What? Okay, so maybe is just too noisy. Maybe let's get the console back. I'd love to turn that noise off. Okay, I don't think async is telling us anything useful. That stuff's not so useful, but this thing, I'd like to know if I'm getting that. 0 matches. All right, I'm going to run it. And I'll just let it run the whole time, like till we start seeing some updates. But are we seeing any? I don't know if we're seeing any receives on this. That may mean it doesn't show. So let's run a search while that thing's running in the background. No, that's not Swift UI. Do I have to walk through them to display it? When itself elements of index is view 1. Okay, got to 63, showed nothing. So let's... And this thing, oh, it has one match. My number of calls gets updated all the time. All right, we're gonna try a little different mode here. We're gonna say this is a list. It's for each. I don't know if we still do this. That's the array. Tower.pega. I think this is saying for each element, tag its name as itself. Because we got sequential numbers that are unique, or because we have numbers that are unique, I think we're okay. Yeah, id : self. And then is that going to do it? Yeah. Let's try. Oh, no exact matches. Let's try that. I'll put a space. All right. So I'm hoping a different way of drawing makes the dependency kind of show up differently and works. Well, oh, interesting. Can we rotate this device? I think it's just R. No. Device, rotate left. Oh, arrow. Oh, what is going on? Now, I thought this was going to do a list. Maybe I don't need the list. I'll just try the elements themselves. So this, I'm hoping, just produces a list of the elements stacked up together. Well, I'm afraid it's going to go across the page horizontally. I guess I should be so lucky. If I start saying 1, 2, 3, 4, 5, I'll feel like I've got progress, but no, I'm not seeing anything. What is magnitude? No. Yeah, it's like my arrays just stay empty. Oh, man. You know, it just tells me I'm missing something out of the model of how these things work. And that's just peg A. Okay, so I'll run it from the top. So a state object says I'm holding on to an object that is basically a published object. Okay, and our stack says, our tower says it's an observable object. So our state object says, I've got this observable object. Register to listen to anything he publishes. The publishing is triggered whenever these values change. Now that is interesting that only changes once. Because when I call peg sub from, I certainly expect remove last to change that pegs. Let's stop in here and look. Okay, I don't know if we'll get the effect of it. Now, how's it getting calls, but doesn't stop on move 1? Okay. Where are we? Thread 5.11. I think I must have bumped something. We're in move 1. Okay, let's step over. Disk is 5. Okay, so we're moving disk 5, and let's print peg A. Well, there's pegs 0, 1, 2, 3, 4. We've removed the 1. I step over, that should update. Yeah, this one has 5 now. I would have thought that my pegs variable, which I clearly depend on, should update, and it's not. I'm just gonna put a little space here to rearrange some deck chairs while I'm not running. All right, so it appears that as far as we can tell, all right, I'm going to continue. The number of calls keeps increasing, so number of calls is getting touched and notified. Is this because I'm accessing it indirectly through pegs instead of peg A directly? I don't know. Okay, well, tell you what. I'll let that run. Let's take another break, a couple of 3 minutes. What kind of plan do I have? Well, maybe I can hard code touching peg A and see if that notifies. I guess I'll try that. I'm short on ideas here. See you in 2 or 3 minutes. Hi, welcome back. All right. So I don't know. My My idea is basically mutilate this even more than it is so far. So the remove last, I'm going to change this. I'm going to say if from is 0, then do something else, something else. Well, let's let, I don't know if I can do this in both branches or I have to declare it equal peg A dot remove last. Okay. All right, so I'm just trying to force peg A to actually work directly, not indirectly through pegs, because I'm worried that the update is only happening if the peg A object is directly touched and that there's some sort of non-transitive thing going on. Grasping at straws? Yes. Okay, peg A is empty. I'm hoping I at least see something happen when peg A changes. No. Okay, yeah. So it eventually dies. That seems a little weird to me. I'm going to change it. 99. That should finish. Why that would fail? That's weird. Pegs, if from is 0, then peg A is always peg 0. Yeah, this mutilation of the algorithm question is really the tricky one. I know there's some issue about, like, if you define your own object, like we did stack, and it publishes notifications, that doesn't carry over, that its container doesn't necessarily publish notifications. So that's kind of one issue. Now, maybe there's just a handful, like, a stack, a queue, an array, some sort of array with an index or something, maybe a pointer kind of thing. Those, maybe I can get a few predefined types going that notify correctly. But I thought the array thing was supposed to do that directly. Now this, like, we're not blowing up. Something's really odd. Let's read up on remove last again. Remove last array Swift. Removes and returns the last element, but it mutates. What's the difference between remove and pop? I guess it's just the question mark on it. Mutating func. Discardable result. You want to gain mutable access via bindings. That sounds like us. Index and offset. Oh, nice. Okay. Operating on a binding. That sounds like good. Binding. Well, there's items of array of string. We got items that are array of int. They do for each on the items. Dollar items of index. All right. Well, this peg has one match to find peg A empty. I just don't understand. All right, let's hide this thing. I don't understand why this isn't showing anything either. All right, I guess the other thing I'm concerned about for visualization purposes, it's like I don't control the algorithm, and maybe this is interacting with this thing about the threads, but I want to run through the steps, and then like I would like to control that this when it comes back here, I kind of want to be able to control that I'm like I'd like to be able to maybe display the arguments, or I don't know. I'm worried I'm going to have to tear the algorithm apart and sort of make a state machine out of it or something and keep track of where we are in the algorithm to handle this other thread thing, because it's like we have to almost invert it somehow. And the pieces we don't care about visualizing, we can just run. But when we get to something we do want to visualize, we better stop it at that point, and like we want to run till it gets there. It almost sounds like coroutines again, which I keep thinking I'm running into, but okay. But these problems are confusing me for sure. I guess my last thing is to maybe this thing should be published too. I don't know. It's not normal to have to listen to on receive for this stuff. I know that much. And what we're seeing is number of calls does get updated. I mean, we'll put the print back in. And let's add a print for pegs updated. Okay. Let's see what we get. Run that. What do we got so far? Pegs updated, peg A. So that's kind of interesting. Well, that's what we suspected was the first one was just initialization. Now we're not getting any. Update received 0 came twice. 1, 2, 3. Nothing on pegs. Hey, pegs updated. Now, what's confusing me is when we were seeing pegs updating, but just they weren't updating at the same pace. All right, let's take that rotation off. Maybe that's just too clever for where we are. And I think we can speed this thing up too. Pegs is getting updated all the time. All right, I'm going to reduce this back down to a more, well, let's do a little slower pace, a third of a second, give or take. We got the rotation off, and see if we can, I guess I can stop this and run it again. I don't know, we did something that changed the way these pegs are doing. I guess I went from pegs instead of peg A, peg B in the previous version that seemed to update once in a while. Maybe let's try this back. Mm-hmm. Well, that almost looks like you could follow along. That was looking better. Let's well, let's go here. I almost want to make this. Can I make this a parameter too? delay takes event. Start at 0. I'll start it. Let's start it a second. Okay. Interesting. It had no complaints about peg A, peg B. Like, oh, they're real. I don't think this is used. Well, that's not the fix I had in mind. UINT 32, boy, that's not much to go on, is it? All right. That's at a 1 second level. Let's do a 2 second level. All right, I should see 5 go to the last one. It's delaying. Nothing's moving now. That's late. Now 5 should go on 4. 3 to the last one. 5 to the first one. Five to the third. First. Oh no, it's the middle. Well, the numbers are always increasing. That's a good sign. Big disc moves. It's just on 33. That's probably okay. Maybe we got to get our zeros. We should go back to that version that doesn't do the zeros, because we're seeing the pauses because of that, I think. And maybe there's just a pause in the updating. I mean, the drop last and the add to the other one, that should be kind of atomic, right? Three, 4, 5. Okay, we should get 3 to the... Oh. Yeah, there we go. 5 to 4. 3 to 1, 2, 3. 5 to the top. Move 4. Move 5. Yeah. That sort of seems kind of like what we want. Every bit we checked as we went, it was okay, except that sometimes it was slow to move the new disc in. So when it did the remove and then the add, to see it go back in was kind of slow. All right, so we expect 5 to go to the bottom, 4 to the middle. Now, why is the delay before we see the 5 and then the 4 pops right in? 5 to 4, 3 moves, 5 moves, 4 moves, 5 moves, 2 moves. It takes a second, but there it is. Then we got to move the 3, 4, 5 back on top of the 2. Okay. 1, 4. 5 to the middle. Yeah, I mean, this thing is doing what it's supposed to. Okay. All right. It's a very primitive first step to my visualization, I'm imagining, but I would love to make these things. Well, I'd like to make them left justified too. But this is the kind of thing I had in mind. I would love to animate so the 5 moves, physically bounces over to the next stack. But that's okay. All right. So, well, I wasn't expecting to animate everything about everything, so I'm okay where we are this way. We've got the ability to show the 3 stacks. We got the ability to count the calls. It requires that you do published in your fields. And then we still have this issue about notification, like make sure to publish values from the main thread. I mean, maybe this thing needs, like, maybe my updating the counter is got to be forced into the main thread somehow. So right now we're running the bulk of it in a separate thread. I guess that other thread is the one that's triggering self number of calls, and it says I'm in global thread. I'm updating the number of calls, and that's why we're getting this message, publishing changes from background threads. So I could call any operator that changes a published value could force a call on the main thread. I guess that would do something. I don't have time to do that today. We just have 2 minutes left. So we're just going to quickly review what went on. So we had this Tower of Hanoi problem. We said there's a recursive solution. We did a version that just printed out stuff or put it in the log. And then we did this variation that accumulates the pieces. This one makes a little bit more work for sure. Okay. But we tried these couple variations. We see that because if you just printed in the log and you weren't accumulating these strings, the last thing you did would be a recursive call. With the strings, you have work to do afterwards. But if it's just a recursive call, you can turn it into a loop. If it's a more complicated thing, well, we took this template. All right. So all this text, let's see, PX, NX, FX, GX, and MX. That's the pieces that we're providing. Everything else is just boilerplate of a recursive to iterative approach. But notice it's still maintaining a stack. Okay, so that's kind of unfortunate. We also did this version. Let's see, is this the right one? this version. Okay, we maintained our own stack explicitly, and we just said anytime you call recursively, we're going to push the work on the stack. So we have the base case move one. Everybody else recursively pushes it. They have to reverse the order to make them do their job, but that's another very straightforward transformation if you want to go from recursive to iterative. If you can get rid of the tail recursion, that's nice. Otherwise, you're introducing a stack that does tracks the work. You can see our stuff in there, but instead of just calling move with this stuff, we push the arguments that we would have called it with on the stack. And when it gets around in the top of the loop, it tries to do the rest of the stack stuff. Okay. And then finally, we also did this memoized version where we said, you're generating 2 to the 63rd or 2 to the nth calls. Okay. So if you had 10 disks, 1,000 or 2,000, depending how you tracked it. But there's only so many moves you can make. And so we reduced something from like 2 to the 10th down to 100 or 150 moves and all memorized and cached. Okay. So yet another way to deal with recursion. So you've got the basic idea of recursive functions that call themselves. You've got tail recursion removal. You've got memoization. You've got the fancier big recursion removal. And we did some work on visualization. So thanks for joining me this time. And I'm off next week. I'm not quite sure what I'm going to do for a little project when I get back, but I'm going to try and keep it to a week, maybe just looking at some algorithm or other. All right. Thanks again. Take care. Bye-bye.